So before we get into the capital asset pricing theorem, that's or otherwise known as the CAPM, C-A-P-T, CAPM, you'll hear that a lot, the CAPM, the CAPM. The CAPM is a valuation equation. It tells us what the expected return of our stock should be, not what it is, but what it should be in relationship to the entire market. So before we get started, I want to draw a little graph here that shows us the risk premium for our regular market. So let's pretend that we have all the same stuff we looked at before, right? Risk, return. This is measured in percentages, and this is measured in standard deviation. Okay, and on this, and on here, we have a portfolio. This portfolio has a risk of sigma, and we're going to make this portfolio a portfolio of the entire market. So our portfolio, or our stock portfolio, is equal to the market portfolio. And often we use the S&P 500 or something similar, Wilshire 5000 or something, to act as if it is the market portfolio. And this portfolio also has its own expected return, sub M for the expected return of the market. Obviously down here we have our risk-free rate. And so what we have here is a very standard, very simple equation that we've already looked at, and we're going to look at the risk premium and the expected return. So what is our expected return? Our expected return is going to be this guy. Our risk-free rate is this guy. And if I try to figure out what my risk premium is, my risk premium, it is nothing more than the expected return. In this case, the expected return of the entire market, right? Expected return of the market minus my risk-free rate. That's it. Okay, so let's just pretend for a second that this is an 8% expected return of the market and the risk-free rate's at 1%. Then my risk premium, I don't need to put it back out over here again. We'll just erase that out. My risk premium is equal to 8% for the expected return of the market up here, and 1% for the risk-free rate. Therefore, my risk premium is 7%. So let's talk about beta. Beta inside of my CAPM equation, let me write it out again. CAPM is a way that I can calculate the expected return of stock I that has, and this stock is going to have a beta I. Note that they're both denoted by the same symbol, times the expected return of the market minus the risk-free rate plus the risk-free rate. Now, if you notice, if I draw a little line here in the CAPM equation, everything on this side of the line is basically the same for all stocks, right? But the beta makes it unique. The beta represents the risk of the individual asset in regards to the risk of the entire market. Let me say it again. The beta represents the risk of the individual stock in regards to the risk of the entire market. And so I'm going to draw a chart here that's just a little bit different than the ones that we've been using. Okay? Instead of putting risk over here, I'm going to use beta. And let's start with the idea, and over here I'm going to put expected return. And I'm going to start with the idea that beta of the market is equal to 1. Okay? So I have my risk-free rate in here somewhere. This is the expected return of whatever it is. And here's a line showing that as beta increases, so does my expected return. Now, if I come in here and I pick some beta, let's go back to pink. If I come in here and I pick some beta, let's fill that out, and I bring it down, this guy has a beta of the market, and we've said that the beta of the market is equal to the number 1. So this is beta 1. Let's do it the other way. This is a beta of 1, which is to say it is the beta equivalent to the beta of the entire market. The risk of the entire market is 1. If the risk of the entire market is 1, then we can say that 1 represents our systematic or our market risk. Okay, 1 is the representation of the entire risk of the entire market. It is going to have a very specific expected return. An expected return of the market. Now you can kind of see the CAPM equation coming into play here, right? I've got expected return of the market. It's here. Oops. My risk-free rate is down here. I have a particular beta of some stock somewhere. And let's figure out what that is. Let's pick a stock. Let's do something aquamarine. We've never done that one. So let's pretend that we have a stock that has a beta of 1.5. Okay, when the beta of this stock is 1.5, it is going to come up here on this market line, on the security market line, and we come back across and figure out that the expected return of this particular stock, I, is equal to, I don't know, 11%. Okay, and the expected return of my market is 8%. We'll stay true to our previous example, and that the risk-free rate is 1%. Okay, where's my color? So if this is the case, what we have is an increase in risk above the market risk. We are no longer measuring by standard deviation. Okay, this is not sigma. All right, not sigma. We are measuring risk in terms of beta. And beta being, if the market risk of beta is equal to 1, then we have to do it, then we have to compare all the other individual stocks based on their individual betas. So let's go back and look at our CAPM real quick. The expected return of my stock, that's a weird color, the expected return of my stock I is equal to, let's pretend I don't know that it's going to be 11%. Let's see what happens. A beta of 1.5, actually it's not going to work because I'm going to have to add it up. Some expected return. Okay. Some expected return, which we don't know what it is yet. I have a beta of 1.5, that's right here. Oh, maybe I should draw the equation. Beta I over E, our expected return of the market, minus the risk-free rate plus the risk-free rate. So then I just plug everything back in. What's the expected return of the market? 8%. 8 minus 1, which is the risk-free rate, close that, plus 1, and that's going to give me an expected return. So 8 minus 1 is 7. That's 1.5 times 7 plus 1. 7.5 is 3.5, so that's 10.5 plus 1. And that gives us a return of 11.5. So my estimation wasn't all that far off. The expected return of the stock I should be 11.5%. Now this is critical when you're looking at a whole bunch of different stocks. And let me show you why. Let me bring over a little Yahoo Finance. And what we're doing is when we look at a bunch of different stocks, let's start with Apple over here and see what happens. Let me just get that over. You'll find that it's difficult to look at what this stock does over a long period of time, especially when we compare them differently than what we compare to the market. Apple looks like it's doing all right. I mean, it goes up and it goes down and it goes back up and whatever. But I don't necessarily know how risky this stock is compared to anybody else. And I can come in here and I can drop, let's see if I can find it. And I can drop the S&P 500 and see what Apple is doing compared to the S&P 500. Wow. First of all, I can see that it is doing better. It is higher than the S&P 500 over time, but it also has an incredible amount of volatility, much higher highs and a couple of lower lows than the S&P 500 has. As such, I would think that it has an increased risk level. And if I scroll down, I can see right here that the beta of Apple is 1.36. Okay, let me go back to the original Apple screen, and I can see it right here as well. Beta, 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 beta. There it is. My beta of Apple is 1.35, 1.36. Okay, what that tells me if I were to come up here to my chart, you know what? Let's draw another one. Let's draw another one, a bigger one, so we can play with it. If I'm measuring by beta, and this is the number 1, so my portfolio is up here somewhere. Here's my risk-free rate. There exists some line. Oh, I missed. Let's just make a bigger dot. There exists some line. This is the expected return of the market. There exists some portfolio equal to 1 for the expected return of the market. 1.36 is going to be over here somewhere. 1.36. This is Apple. Okay? And we denote it by saying 1.36. We denote it by saying beta AAPL. The beta of Apple is 1.36. Therefore, if I walk up this line up to my security market line, I have some relationship where the expected return of Apple should be greater than the expected return of the market. And can we figure out what the expected return of Apple is? Absolutely we can. But we have to make some assumptions. Okay? So let's go back to the CAPM. I would expect to see this on your exam in the future. That says that the expected return of Apple is equal to Apple's beta, Apple, times the expected return of the market minus the risk-free rate minus the risk-free rate plus the risk-free rate. And so we're just going to make some assumptions. I'm going to tell you that the expected return of the market over the next year, since it's not great, we're going to just say that it's 6%. Okay? The risk-free rate right now is 0.25%. That's the actual number. It is nothing. Plus 0.25%. It is nothing. And what was the beta of Apple? Tab. The beta of Apple was 1.355. So let's just make it 1.36. Okay. So the beta of Apple is 1.36. So I can turn around and make a calculation about what I think Apple's going to do in the future. Apple's going to, now we calculate the CAPM. 1.36 times 5.75 plus 0.25. So what is 1.36 times 5.75 is equal to 7.82. So this is 7.82 plus 0.25 plus 0.25 equals 8.07% return. The expected return of Apple given these scenarios is 8.07. And if I come back up to my graph and I know that what did we say that the expected return of the market? The expected return of the market was going to be 6%. If this is 6%, then I would expect Apple to be a little bit higher than that at 8%. Given those estimations, that's how we use the CAPM. Now the CAPM is very powerful because every stock, let me go back and show you all the other ones. And you pick a stock of choice. Anybody? Let's pick Boeing. There's Boeing right there. I click on Boeing and Boeing comes up. Boeing has a beta. It has a beta of 1.36, not dissimilar from Apple's, right? And so this tells me right here that, let me see if I can make it bigger. 1.36, that Boeing and Apple are both riskier than the market. Let's find a stock that is not as risky as the market, something that's been around for a long time, like maybe Johnson & Johnson. Johnson & Johnson should not be as risky as the market. Good. The beta of Johnson & Johnson is 0.879. So if I go back to my graph, I'm going to know that 8.7, let's do it in yellow. 0.87 is going to be here somewhere, 0.87. This is the beta of Johnson & Johnson. Okay. If I were to calculate this up on my security market line, the expected return should be somewhere beneath 6%, probably like 5 or 4.5 or something. And we can calculate it out. As a matter of fact, let's do it real quick just for practice. Okay. CAPM is equal to beta, in this case of Johnson & Johnson, times the expected return of the market minus the risk-free rate plus the risk-free rate. Excellent. So what was the bond? What was the beta of Johnson & Johnson? It was 0.87. 0.87, 0.88. So 0.88 times 6% minus 0.25% plus, this is a bracket, plus 0.25% gives me 5.75 times 0.88. So that's going to be, equal to 5.06 plus 0.25. 0.25 is equal to 5.31% is going to be the expected return of Johnson & Johnson. And if we go back up to our graph, we see that that's going to be the case here. This guy right here is 5.3%. How come this one is lower than the market? It's not that this one is lower than the market because of its beta. It's that beta represents that lowered risk. And remember, we calculate all this stuff based off of standard deviation. So I bet if we were going to go back to Johnson & Johnson and look at the 5-year and look at the volatility of the 5-year compared to the S&P 500, that it is not, well, since this is in percentages, it's hard to measure, but it's not as volatile as the S&P 500. And it's not a difficult argument to make. It looks like there's a bigger upshift, a bigger uptick, but the volatility, particularly here at the end, has declined for the S&P 500, and Johnson & Johnson has remained up a little bit as we appear to go into a downshift recession. So yeah, that's probably the case. It's not as far off as I thought it was going to be. Certainly not as powerful as the Apple distinction, but there's less risk there. So there's going to be a lower expected return. And so that's the case for beta. It's not much more complicated than that. What you need to remember for the class is this equation right here. You will be calculating expected return based off that beta, and if you get the expected return of a particular asset, you need to be able to calculate the other stuff. So in some cases, I might give you the expected return here, and you might have to calculate the beta or the risk-free rate or whatever. And that's going to be some simple. Hopefully, it'll just be some simple algebra for you. So have fun with CAPM. We will be using this as we move forward into capital budgeting. So take the time now to practice, do a couple of problems in the back of the book, do a couple of problems on your quiz, and have fun with it.